Good morning, Jeremy. I wanted to go ahead and make a video solution to your chapter 2 questions. Number 3, write the equation in standard form. So this is the form that we're looking for. And you're given a vertex 2, 5, which are the coordinates of h and k, and a point that satisfies the equation. So the first thing you do is you plug in the vertex hk into the equation. So you get something like this. Then since I gave you a point, what you're going to do is you're going to plug in x for 0 and y for 4, because that's what you were given, into this equation. So the only unknown you will have left is a. So from given point to solve for a. So plug them in. So that's what I did here. And then I started simplifying. This is negative 2 squared, which gives you 4. Subtract 5 from both sides gives you negative 1. Divide through by 4. So then a is minus 1/4. And then you take that a and you plug it in right here. And that's what you should have got. Number 4 says, given the equation, find the solution of f of x equals to 0. So really, this was pretty, maybe it was the directions that were confusing you, but it really was that easy. Just set it equal to 0, factor, and then set each one of these equal to 0 to solve for x. So x equals 6 and x equals negative 4. And for problems like these, what WebAssign wants you to do, and it tells you this, to enter them in from lowest to highest separated by a comma. So that's how you should have entered it. Okay, so for multiplicity, multiplicity is how many times a particular number is a 0 for a given polynomial. So for example, if I give you this polynomial, I can go through each one of these and tell you what the multiplicity is. So for this term, since it's raised to the 4th power, I can say the 0, 3 has multiplicity 4. For this factor, since it's raised to the 1st power, I can say the 0, 5 has a multiplicity of 1. And finally, for this factor, which is squared, I can say the 0, 8 has multiplicity 2. So for your problem, you should have factored it, and you would have noticed that the 0, negative 1 has multiplicity of 2. Okay, then you seem to have a lot of trouble with synthetic division. So this is what you have to do. So this is divided by x minus 5. So that means x equals 5 is the factor. Then what you need to do is you need to write the coefficients of each term. Now notice in this case that there is a missing term. You start from the highest power of x and you go all the way down to x to the 0. You have a missing x to the 1st term in the equation, so you have to substitute a 0 in. And then from here, the process is bring down the 3, you multiply. 5 times 3 is 15. Then you add. You get 4. 5 times 4 is 20. You add, you get 20. And then 5 times 20 is 100. And when you add these, you get 0. So if you divide this polynomial by this polynomial, this is what you get. These are the coefficients of a polynomial. Since there's 3 terms, I know that x squared is my highest power. And these are those coefficients, A, B, and C. So the next one is the same kind of deal. So this is saying take this polynomial divided by this polynomial. Notice that it's to the 4th power. So I have a bunch of missing terms this time. So we have missing terms for x to the 3rd, x squared, x, and 0. So all those coefficients are going to be 0. So when I go ahead and do this synthetic division, I know negative 5 is my factor. And I write the coefficient of x to the 4th, but then I have to include all these other ones as well, all the way down to the x to the 0, or the constant. But then from there, the process is the same. I bring down the coefficient, I multiply this times this, I get 20. I add, and I get 20. This times this gives me negative 100. I add, I get negative 100. This times this is positive 500. I add, I get 500. This times this is negative 2,500. And this is what I get, negative 2,500 here. So then again, since I have a 4th order polynomial divided by a 1st order polynomial, I know I'm going to get a 3rd order polynomial as my answer. So this is the coefficient in front of x to the 3rd, x squared, and then x, the constant, and then This is my remainder term here. Finally, this one asks you to write in standard form. So that means we're looking for an expression a plus bi. Okay, so when I have a complex number in the denominator, the process is to multiply by the conjugate. So if this is 4 minus I, then the conjugate is 4 plus I. So I have to multiply the top and the bottom. So when I do that, I have to distribute the 10 to the top. So I get 40 plus 10i. And in the bottom, the reason you multiply by the conjugate is to get rid of the imaginary term, the I term. That's the whole point of doing this division or doing the conjugate. So when I FOIL this out, I should get 4 times 4 is 16. Minus I times I is minus I squared. Minus I times 4 gives me minus 4i, and positive 4 times I gives me positive 4i. And you'll notice that these terms drop out, and I'm left with 16 minus I squared. But I squared equals negative 1, so I'm going to substitute that in for I squared, which I'm showing that here. And 16 minus the negative 1 is 16 plus 1, which gives me 17. So I now have no imaginary terms, no I terms in the bottom, and that's what we want. So I ended up with a real part, which is the A, plus an imaginary part, which is the B term. So writing them out as A plus BI, I get 40 over 17 plus 10 over 17i. All right, I hope that helps. If not, let me know. I'm still in California. I'm flying home today. It's Saturday. Sometime tomorrow, I'm going to send you some problems both from chapter 1 and chapter 2 and give you a chance to redo those problems. And then I will go in there and give you some partial credit if you get them right to bring up your test scores for chapters 1 and chapters 2. If you want me to do the same kind of thing for chapter 3, could you just let me know? Because I did put your score in last night. You did better. So I'm going to let you decide whether or not you want to try to redo problems from that chapter. There's one more thing I wanted to talk to you about. So when you're in Blackboard and you're in an assignment, I just picked the first assignment. If you come here first, they have guided notes. So click on these notes. And they have this for every section. As you're going through the book, you could be filling these in, and it, gives you some other things to practice while you're going through the lesson. You can also print out the solution to the notes, so then you can kind of come back and make sure you got the right information in here. I think maybe using these guided notes might be helpful to you. I'm not sure. You seem to do better on the homework than you're doing on the tests. And you could use this on your tests to help you. And I think it'll maybe help you focus a little more. I'm not sure. I'm trying to figure out ways to help you, but definitely I think maybe using these guided notes would help. Also, there is a PowerPoint for every lesson. I mean, as you know in the book, there is also little things you can look at, but I'm just going to try to pop this open real quick. I don't mean to make this video longer than it needs to be, but this is showing you all kinds of stuff, goes through example problems. So the PowerPoints are really useful as well. So maybe what you could try doing is going through the lesson in the book, filling out the guided notes, and then looking through the PowerPoint. Those are always available to you. Okay, so hope this helps. Let me know. Thanks. Bye.